everybody. Today we're going to talk about annuities. We should really start with, well, what is an annuity? So an annuity is a sequence of equal payments made at equal time periods. So this is, we are putting money away and we're going to do it either every month or every week or every year, but we're going to do equal payments at equal times. And then the value of an annuity is the sum of all the deposits that we've made plus any interest that has been paid to us. So we have a couple of equations that we're going to use. We'll start with this one. This is the simplest one. It says the value of the annuity can be calculated using this equation. A is equal to P times, and I have these big parentheses, and then inside I have parentheses 1 plus R to the power T minus 1, and that's all divided by R. A is the amount of the annuity, so this is our future amount. P is the payment that we're going to make every time. R is the interest rate, and we're assuming that this interest is consistent, so it's always going to be the same. We're going to write that as a decimal, and T is going to be the time in years. So I want you to notice that this is only for contributing money one time every year. So if we were going to make an annual payment, then this is the formula that we would use. On your calculator, you do not have to use these square brackets. I just do that to really make it stand out and show that I had two sets of brackets when I was doing this equation. If we have more payments that we're going to make, so say we don't want to make one payment a year, we want to make maybe 10 or 12 or 5, some other number, any number n. So our equation for making n payments and having that many compoundings a year is A is equal to P times big parentheses 1 plus R over n parentheses to the nt minus 1, and then divided by R over n. So now, A is still the future amount, P is still the payment you're making, R is still the interest rate as a decimal, T is still time in years, but N is how many payments and how many compoundings you're getting a year. So I want you to pay attention to the fact that this is contributing N times a year. So the first one was one time a year, this is multiple times a year. When you go to put this in the calculator, you may find it helpful to put parentheses around the R over N, and I, of course, will show you the calculator. Okay, so example 1, we're going to find the value of a periodic deposit of $750 at the end of each year for 20 years, given that we get 2.5% annual. So this is only a one-time a year deposit. So because of that, our formula is the A equals P times 1 plus R to the T minus 1 over R. So only one time a year, we don't have to have the bigger equation. We're going to start plugging things in. So this 750, that's the payment we make every time. 20, that is our T. 2.5%, this is our R. So you can see I plug that in. I have 750 times 1 plus 0.025 to the 20 minus 1 over 0.025. I got 19,158.49. Okay. So I'm starting with 750, and then I have parentheses, and then I have another set of parentheses. So it's important that you see that there's two sets of parentheses here. So I have the 1 plus 0.025. I'm going to raise this to the 20th power. Then I'm going to subtract 1, close that second set of parentheses, and then divide by 0.025. So if you don't have two sets of parentheses, it's going to be wrong. So make sure that you're seeing both. I like that Desmos makes the first set a little bit bigger, so you can kind of make sure it's open closed. And I got that same value, $19,158.49. What if we wanted to know how much of this amount was interest? So of this $19,158.49, what did we put in and what did we earn? So what we need to find out is interest will be the total that we have minus the amount of money that was deposited. To figure out our deposit, we say we paid $750 20 times, which is $15,000. Then the interest will be our total, $19,158.49, minus the $15,000, which says we earned $4,150.49 in interest. So remember, total minus deposit, there's your interest. This will come up multiple times as we're doing this. So let's try another example. This time, let's find the value of a periodic deposit of $1,400 at the end of each month for 15 years, given we get 4.5% interest. So this one's different because we have each month. So we're going to use the different equation. This time we're using the bigger one. A equals P times big parentheses, then parentheses 1 plus R over N to the NT minus 1, and then the whole thing all over Rn. So you want to go through and kind of like pull the pieces apart. So the $1,400, that's going to be the P. You can see that in the formula. 15, that was our time. Again, you can see that in the exponent. The monthly, this is 12. There's 12 months in a year. And then 4.5%, that is your R. That's how much interest you're earning. So all those things got plugged into my formula. 1,400 times parentheses, another parenthesis, 1 plus 0.045 over 12 to the 12 times 15 minus 1 over 0.045 divided by 12. Again, depending on the calculator you're using, there are some steps you can do to make this easier for yourself. You can put parentheses around the denominator. That's going to help. You can also go ahead and multiply 12 times 15, which is 180, and that might help you also. I will, of course, go to Desmos to show you how to put it in there, but I want you to have the right steps so that we're set up to get this right. Okay, so this time I have 1,400 parentheses again, so we always have to remember that we have that double parenthesis, plus 0.045 divided by 12. This is to the power 12 times 15. Now watch this. See how it jumped down? It wasn't keeping the 12 times 15 together, so I'm going to put another parenthesis up here because I want to make sure that both the 12 and the 15 are in the exponent. Then I can go back down and say minus 1, close the parenthesis, and then divide by. In Desmos, you don't have to have the parenthesis for the 0.045 divided by 12, but if it makes you feel better to have it, like to make sure that's there, then that's not a bad idea. And here you can see my answer. So we have $358,980, and I'd call that 54 cents. So definitely a lot more money on this one. So just like the last one, I would like to know, well, how much interest did we earn? So we go back to saying, how much did we deposit? So we did $1,400 for 15 years, but every month. So 1,400 times 15 times 12 is $252,000. So that's the amount of the deposit. The total was $358,980.54. So we subtract those two, and it says the interest earned was $106,980.54. So a lot more interest because we put in a lot more money. We had a higher interest rate. So good value there, right? Got a lot of interest on that one. All right, so if you're looking at this and thinking like, this is a lot, I'd agree with you. These are big formulas, but I have good news. There is lots of technology to help us out. So this is what I tend to go to is this financial calculator. So this is the link to use. I will link it when I post this to you so that you have this link that you can just click on. So what we're going to do is we're going to go back and do those examples again using this calculator. So luckily things kind of feel the same as to what we're going to do, but pay attention, there's two P's here. One of them says present value and one of them says payment. So the payment is what we were calling P earlier. Future value we were calling A. The rate, it knows it's a percent, so we're not going to put it in as a decimal. The periods, you have to do N times T. So you have to do the number of times you're going to make a payment and the number of years you're making a payment. And then pay attention to this last one where you can change the compoundings and you want it to match the N. So there's a few things to hit, but it's really going to be so much easier than doing it kind of like by hand where you're having to put everything in the calculator on your own. All right, to start, make sure it's on the end. The present value is 0 because we didn't have one. The payments that we said we were making were $750 a year. The future value is what we want to find. The interest rate was 2.5, and notice I put 2.5, not 0.025. The periods were the total number of years, which were 20, and then we want to say the compounding was annually. So I go to the future value, I hit the FV, and it says $19,158.49. There is a negative, that kind of just shows it's our money. Every time we're doing this, there will be a negative somewhere, so just pay attention that you can drop the negative, but this is your answer, and all I have to do is kind of click along to get it. So let's go back to example number 2. So for number 2, we were putting $1,400 away. Again, we want to find the future value. Let's leave that blank. We were getting 4.5% interest, so we put in 4.5. The period, so you need to do 12 times 15, which is 180. So you do have to do that one slight calculation on your own. And then it was monthly, because we had 12, right? Every month we were putting money away. And again, the future value, here's our $358,980.54. So real quick to get that number, again, I'll say negative, no big deal, don't worry about the negative. So now that we have this financial calculator, this is going to be my go-to. If I want to do something, I'm going to go to the financial calculator. I'm not going to use it using the bigger calculations. There's no need for that. All right, so let's try another example. This time I twisted a little. We want to find the periodic deposit needed to have $3 million in 30 years if you make a deposit monthly in an account earning 9% compounded monthly. Okay, so this is the one where we're making more payments. So if we were going to use the formula, this is the one we would use, but we're not going to do that. We're going to say instead, hey, this $3 million, this is our A. This is our future value that we want to have. 30 is our time, so that'll be important. We're making monthly payments. This is in, and we're getting 9%. This is R. So I am going to go over financial calculator, and we're going to solve it that way. So I'm going to hit reset. Reset just clears everything out and says, okay, present value 0. And then the payments, that's what we're looking for. The future value is $3 million. Our interest rate was 9%. And then the periods, well, we had 30 years and we're going to make 12 payments a year. So that would be a total of 360. It's on monthly. Go to payment and it says $1638.68. If you decided to use the formula or you just feel like you want to also, here's all the little parts that you would put in there. The only difference would be you're trying to solve for P in this one, so at the end, if you want the long way, you would have to take everything except the P, move it over to the left. You would need lots and lots of parentheses when you went to put this into the calculator, but using our way, you get the same thing of $1,638.68. So my high recommendation is to use the financial calculator. Do not try to do this the long way. No extra points for that. So just like before, if we wanted to know how much interest we earned, we would have to look at the comparison between how much did we invest and how much did we have at the end. So the total is what we were trying to get, is the $3 million. The investment would be the $1,638.68 that you did 12 times a year for 30 years. So you plug that all into the calculator and it says the total interest is $2,410,075.20. Example 4. You deposit $600 at the end of each month for 9 years at 4.5% compounded monthly. Then you stop making payments. But you continue to earn the 4.5% for the next 11 years. How much money will be at the account at the end of the investment period? So we have two things that we need to do here. First, we need to figure out what happens for those 9 years at 4.5%. Then we can deal with what happens the 11 years after. So I want you to think of this as a two-part problem. There is not a formula that does this all at once. So let's start with the first part, where we're depositing $600. So this is our payment. And then the 9 years is our time. 4.5% is our interest, and again, this is monthly, so this would be our N. And we started at 0. Our payment this time was $600. We want to know the future value. We had a 4.5% interest rate. The period, we had 9 years where we're making payments every month, so 9 times 12 gives a total of 108, and once again, this is monthly. So I go to the future value, and it says $79,706.76. So here is our future value. This is at the end of 9 years. So now we have $79,706.76. Okay. We have 11 more years that we're going to continue to get the 4.5% interest, and we're going to assume it's still compounded monthly. So what do we want to do? We want to go back to our compound interest formula that says A equals P times 1 plus R over N to the NT. So we're looking for A. We're starting with $79,706.76. We have 1 plus 0.045. Our in, that's 12. And we have 11 more years, so this is 11 times 12. To simplify that, I'm going to do 11 times 12 on my calculator. That gives me 132. So I'm going to put in $79,706.76, 1 plus 0.045 over 12 to the 132. So for this, I'll go to Desmos. I have 79,706.76, parentheses 1 plus, I have 0.045 divided by 12, close my parentheses, I go to my exponent, and luckily we already multiplied that out to 132. So it says my new total is $130,637, and we're going to call that 80 cents. We'll go ahead and round up. So here's our new future value, $130,637.80. So just remember, sometimes you may have to do one calculation, finish that, then do the separate calculation, because they're using two completely separate formulas. We just can't put them together. All right, let's look at a payout annuity. So the payout annuity is looking for you getting money. So there's being a set amount of money in the bank, and we start wanting to withdraw. So the payout annuity with fixed payments means they're not changing. You're going to get so many R dollars N times a year for T years, and the payments are drawn from an initial amount P that was earning R% interest, compounding N times a year. So it's very similar to what we were doing before. We're just solving for something different. Now we're solving for withdrawing instead of depositing. So again, we have a formula. I have P is equal to R times parentheses 1 minus parentheses 1 plus R over N to the negative NT all over R over N. I'm not going to do this with the formula. We're going to use the financial calculator that I showed you. So we're going to have to make a slight little change to make it happen, but it's not going to be a big deal. So let's try that. Say we want to be able to withdraw $55,000 a year. Like we're thinking we're retired. We only need $55,000 a year for 30 years. Because we're going to retire for a long time apparently. So our account is earning 4% interest. How much will we need in our account at the beginning, right, so that we can draw this out? So what's important here? So the $55,000, that is going to be our R. That's what we're withdrawing. 30 years, that is our time. We're taking this out like one time a year is our assumption, and then the 4%, that is our little r. So this time we are looking for the present value. We need to know how much money needs to be in there, and we are going to take out $55,000. So I'm going to make that negative to show I'm taking that money out. In the future, after we keep taking out this money, it's going to be worth 0, but that's okay. We got our money out of it. We were earning 4% interest. We had 30 years, and we're doing this annually, so don't forget to change that annual. So what do we need to know is how much money do I need to start with? I need to start with $951,061.83. Because our P was equal to $951,061.83. Let's try another example. We want to be able to withdraw $2,500 each month for 20 years. Our account earns 7.5% interest. How much will we need in our account at the beginning? So $2,500, that is our payment, like our R. 20 years, that is our time. 7.5%, that is R, our little r, our interest. But in here it also says each month, so we have 12. We'll hit reset. We don't know our present value. We know our payments are going to be $2,500, but we're paying ourselves, so we're going to call that negative because we're reducing the amount of money. In the future, we want to have nothing left in our account. We want to use all of our money. We had 7.5% interest in the period. So this time we had 12 payments a year, and we're going to do this for 20 years. So this is 240 times we're going to pay ourselves. It is monthly. So go to present value. It says you need $310,330.33. So we found out we need, at present, $310,330.33. If you wanted to see how much interest you had earned, you could kind of do this comparison between how much was put in there and then how much you were able to withdraw. We were able to withdraw $2,500 12 times a year for for 20 years. We have a total of $600,000 we were able to get paid, but we started with $310,330.33. So we're going to take that difference, and that says $289,669.67. Let's try one more. This time our account has $450,000 saved for retirement. We are earning 3% interest. How much can you withdraw a month if you want to use the account for 25 years? So it says we're currently starting at $450,000 and we're not adding anything to it. We're just going to leave it alone. And it's earning 3% interest. So we want to know if this is what we have and we're going to start making these withdrawals every month, how much can we take out? So this $45,000, this is the present value. 3%, that's our R. We are going to do this a month, so this N is equal to 12. And 25 years, that is our time. So what are we looking for is how much money can we take out? So our present value is $450,000. We're looking for our payments in the future. We want to deplete that account, so it'll be 0. The interest rate was 3%. The periods, remember, you have to multiply together. We're doing monthly 12 for 25 years. That's a total of 300 payments we're going to take out. It was monthly, so that's already set, and then we hit payment. This says you can withdraw $2,133.95 every month. We found our R was $2,133.95. Remember, it was negative because we're taking it out, but we wrote right at positive here. If you wanted to figure out the interest, how much interest did I earn, you could look at, well, how much money do we end up receiving? So 2133.95. Remember, we're going to do that 25 years, and we're going to get a payment every month. Gives a total of $640,185. Subtract from that the $450,000 we started with. So 640, 185 minus 450,000 says the interest was $190,185. Hope that helps. Please use the financial calculator. Do not try to put all this into the calculator the long way. It'll just be too much work.